Hey there YouTube, welcome to another episode of Kevin and Francis Astrophotographer. Today is this video is the moment you've all been waiting for with bated breath to see my StarTools workflow. It's not great, it's not perfect, but it does the job for me. So stay tuned, I'll take you to that now.
Okay, so let's talk about my StarTools workflow. So let me open up StarTools for you. It's by no means perfect software. Everybody has their own brand of software that they use, and this is what I use. Gets me most of the way there. First things first, I'm going to go find my stacked file from DeepSkyStacker. Get my words right. And load that up. Now it's going to ask you a few questions. If you just stack your fit files or your raw data files, then it's linear, and usually you choose that. But if you're talking about using some other types of files that have already been stretched, then you want to look at the other three categories and then choose that, so that StarTools knows what it's dealing with as it goes through the process of stretching and monitoring your photo. All right, first thing I'm going to do is I'm going to bin it because it's a large file, and it doesn't need to be this big, and the smaller it is, the less resources on my computer that it takes. Alright, so a large portion of this video has a lot of dead time in it, so I'm cutting it out. But what binning did, it took a while, but because it was a large file, it cut it in half, and now StarTools is going to work a lot faster. So next thing is the auto dev. So I want to see where they're stacking artifacts, and I want to take those out. Which, for this one, the Crescent Nebula looks pretty good. Don't really see a whole lot of stacking artifacts. So I'm going to accept this as it is, and then I'm going to move on to the next step. Okay, so the next step here is to go ahead and crop it. So cropping is used to get rid of stacking artifacts, and a lot of times those are in your outer edges. And like I said, this one doesn't look like it has a lot of stacking artifacts. I know there's a lot of nebulosity around the Crescent Nebula itself, so that doesn't look all strange. So I'm going to crop it a little bit here, about 10 pixels on all four sides, and that should be enough. And that's going to help StarTools, because if there is any stacking artifacts, those are going to be gone. Alright, so now we've got that taken care of. Now let's take care of getting rid of this gradient. There's a massive gradient here. We got to get rid of it. Now I'm going to use narrowband as my option here. You could just choose the gradient option, or you can choose vignetting. So if you've got some vignetting that occurs, you can use that. The StarTools gives you different options to choose from. Even if you have amp glow, you can set it to amp glow. You can use a mask to show where the amp glow is, and you can pull all that out with this software. So here in this particular case, I don't see a lot of the amp glow, which I think there is some, but it's not very noticeable to me. So I'm using narrowband because I used a filter that is a narrowband filter, or a dual narrowband filter, and that's looking pretty good. So it's taken away most of the gradient. This is not by no means the final picture, so this is actually a pretty good step. And so I'm going to accept that as well. So keep it, and then I'm going to move on to the next step. Alright, so the next step is you've done all of this, you've cleaned off some gradient. Now we got to go do the final stretch. And so to do that, you go back to auto dev, and here's where you start to make the adjustments necessary to get to a photo that you're starting to like. Alright, so the previous stuff is simply just clean up all the crap that comes with taking these and stacking the photos. And so now what I'm going to do, I'm going to select an area. Okay, this is my region of interest, which is the Crescent Nebula itself. I'm going to adjust the influence outside of the region of interest, and then I'm going to let this do its thing. And what you'll see is when it's done, you'll see what looks to be your final, almost your final photo, right? You're going to take a lot of that brightness out, and you're going to start to expose the nebulosity. And here I'm ignoring fine detail just to show you what that does. And it will darken the photo, and maybe it will darken it too much, meaning your background is going to be too dark. And I'm not too worried about the color gradients you see here. Those will be taken care of here shortly when we get to that step. So I don't want the background to be too dark, and I actually don't want to lose out on any data surrounding my or within the Crescent Nebula itself. And again, so StarTools is keeping track of all of this. A lot of what it's keeping track of is where all the noise is located, so that later on we can pull all the noise out that it's been tracking. So you can see where I've changed the region of interest and it got brighter. The background also got brighter. Some of the noise got brighter. Some of that color cast also got brighter. So here's where you want to make sure that you're comfortable with what you're going to end up with before you move to the next step, because it's going to be a little bit harder to go backwards and fix it after this point. Alright, so here in this case I'm done, I got it, I think I'm happy with this, and so we're going to move on to the next step. Alright, so my next step is to get ready for deconvolution, but I'm going to start with contrast. And here with contrast, I'm just going to let that run as is with the full mask. Okay, so this is almost done. With the full mask, it is looking at every detail in the image and is working on updating the contrast. Now, at the bottom with StarTools, you always have the option to make changes to your dark anomaly filters and things like that, your precision, how accurate do you want this to be in doing its analysis. A lot of times I keep all that the same. Very rarely do I change it because it's that good. And so now I'm just going to work on sharpness, and I'm going to leave a lot of this the same as I did with contrast and just let it go and do its thing. And now the reason I want to do this is because for deconvolution is a star mask, and to be able to identify all of the stars, I want to make sure they're clearly identifiable to StarTools. Now, there's enough color cast here and color noise to kind of make it difficult for StarTools to get enough of the stars. So I want to make sure it can get what's necessary in the deconvolution step. So there are times where you can just skip these two steps. You don't have to do sharpening. You don't have to do the contrast, and go straight to deconvolution and begin that process. So here we are. I'm finishing up sharpness here, and I don't know if you noticed with the contrast, it darkened it up a bit. Sharpness is going to look at the difference here before and after. You see that it's much more sharp image, which is okay at this point. All right, so now let's go ahead and deconvolute. Okay. So here I'm having it automatically generate the star mask. If you did this another way, you did this manually, you would have to go in and hit every star. And I don't know if you looked at this photo that I have here. There are a lot of stars here. So I'm going to let StarTools figure it out. And right there, it's figured out where the brightest stars are and the largest stars, and it has masked them out. And so now it's going through the process of deconvolution. Now here, I do at times adjust this, and where I would adjust is with the radius down here on the left, and I'll get to that here in just a second. Okay, so that took more than 2 minutes to complete. So I'm going to do before and after just to kind of see the difference, just to understand that it's doing enough with the stars and it's not deforming the stars in the process. And then, so what I'm going to do here is I'm going to select an area, and just for testing, I'm going to adjust the radius to 2 pixels instead of 1.5, and I'm going to let that go and see what happens. Do a little before after. Okay, and looks pretty decent here. So I think maybe I'll go ahead and apply it to the whole picture. See what happens. We'll do that. Apply. Which that really says all. Okay, so let's take a look at all of the stars and see if we've got any deformation. So a couple more before after checks to see if there's any other stars that look like that. So there we go. There we go. Those are the stars that were deformed in the process. All right, so let's take it back to where it was. 1.7, probably not enough. But in the end, I took it back to 1.5. So I'm going to skip ahead to the next step. All right, finally back to where we were. That was almost a good 8 minutes of wait time there. So deconvolution, as you read, is a big process, and it's an important one. So now that I've verified all the stars are still round and not distorted, I'm going to keep it, move on to the next step. Okay, so now it's time to do HDR. And so high dynamic range is what HDR stands for. And here I check all of them just to see. And a lot of times what I'm going to end up doing is just highlighting some of the details of the shadows. But first things first, let's reveal all and see what it shows me. And you can see the algorithm at the bottom. So at the bottom where it says algorithm, I'm doing reveal all. At the top, you can pick and choose the presets. I typically don't. I typically work with the algorithms at the bottom. So here, the reveal all is complete. And so I'll go and do a before after, and I'm looking for what it did, what the changes are. It didn't do much here. So let's go to the next one, which is to reveal the DSO core, which is the Deep Sky Object Core. This really doesn't have a core based on how this picture was taken. So I don't expect this to do much. So it's done. And if you go ahead and take an opportunity here to look at the before and after, you'll see it looks exactly the same start to finish. So let's look at the next algorithm. Taming highlights. Taming highlights is one that I do use very often in my post-processing here. Again, it just depends on the photo. And in this particular case, taming highlights did absolutely nothing for me. Okay, so that's done. Now, go ahead and do the before and the after, and you can see there's not much difference between before and after. So let's go on to the next one. Optimized hard. So, and there's also an optimized soft, which is the last algorithm. So optimized hard, it basically just takes the entire image and brightens it up. So if you want to see what that looks like, let's again look at the before and after, and you can see how it brightens up the nebulosity in both the nebula all the way around. All right, so I'm happy with that. That's enough for high dynamic range at this point. And so now let's get the colors right. So let's go into color. There's a few options here in colors. You can go with the legacy. Well, first things first, you want to fill the mask because you want everything to be colored correctly. But you can do consistency, you can do legacy, or you can do Hubble. So it's got some presets at the top there that you can choose from, and the first preset is consistency, which for me, when I started using this version of StarTools, I was surprised to see that that's the base option, because it just doesn't look that good to me. But that's just me. If it's, if your picture comes out really nice based on that, then absolutely go with it. I just didn't like how the Crescent Nebula looked in this color option. And with this color option, so I decided to go ahead and click on the Hubble palette and make a few changes with that. So let's let StarTools finish calibrating the colors here. Here we go, changing it to Hubble. All right, so now that it's changed to Hubble, it's going to go through the process again, and it will give you a different look than what you saw before. Okay, so I like that better. Again, I was using a narrowband L Pro Enhanced or L Enhanced filter, and so because that's a dual narrowband, it makes sense to utilize the Hubble palette in this particular case. And look at that, it looks a lot better than it was. We can make some adjustments here with the sliders for red, green, and for blue. So if there's too much red here, you can certainly pull it out by increasing that on the slider side there. If there's not enough green, not enough blue, you can pull those back in. What StarTools does is it does an initial analysis of its own, and it determines what the colors should be for each of the objects or pixels in the picture, and then you can make adjustments to how you like it or how you want to see it. Okay, I think I'm happy with this. I'm doing a little before-after check just to see what it looks like. And if I like it, I'll keep it, which I do. I like it. Okay, so now comes the fun part. Let's get the noise out of this thing. And so to do that in StarTools, at the very top it says track. It's highlighted in green. You're going to turn that off. It's going to give you some options. And you're going to put or check the remove noise. And then at the bottom, you're going to adjust the grain size. And you want to adjust it to where your photo is blurry. Right? So that the noisy spaces, the noisy parts turn into a blur. And so you can adjust that. In my DSLR photos, that grain size is pretty high. It's about 13, at least for me. With this particular camera, this ASI 183 MC Pro, 6 pixels is decent. That's a good grain size to work with. All right, so after about 8 minutes, it took that long, of analysis and scale extraction by layer, StarTools is now working on noise reduction. Okay, noise reduction done, checked it out, and let's move on to the next step. Alright, so closing in on the final photo and looking at it, looking at all of what I see is left in terms of nebulosity, all over the photo, which I know is there. What else can I do? What other little things can I address? And maybe I can make the stars better. I don't know. This was 3-minute exposures taken in the Blue Ridge Mountains. I think my polar alignment was actually pretty good. So I'm going to go ahead and do an automatic star mask here. And let's see if we can make the stars better. Typically, this makes the stars look fake. So it's not really the best option for star reduction or star repair. I think there's a lot of work to do with their algorithms here. So here it's picked out everything possible, and so I'm going to have to get down to just stars. I'm going to do a couple of shrinks. I'm going to hit shrink, and it's going to mask less and less of the pixels that are out there. Okay, and then I'm going to go through the Crescent Nebula itself, and I'm going to start removing some of the pixels that are highlighted there as well, because they don't need to be. That's nebulosity, that's part of those are not stars. And so you just go through and you click them. This is the flood fill, so if you click on something and it's a star, you just click on it again and it fills it right back up. So I just wanted to go through this for you guys just to see, StarTools has this capability. I just personally don't like the algorithm per se. There's a lot of room for improvement here, and I think there's other methods for those experts who have Photoshop and GIMP skills to be able to make the stars look a lot better than they do than they would using this tool here. And this is a lot of work. So the star mask algorithm here is not as accurate as for what it is with the deconvolution, and I kind of like that better. It does a better job of finding the stars. So anyway, those are just some opinions on this, but you can see here I'm just clicking on what is a star, and that's just re-highlighted, and things that are nebulosity, I pull that right on out. And so most of the picture looks pretty good at this point. So maybe do one more shrink and then a grow just to get rid of all of those erroneous pixels that are selected. And I'm left basically with stars, and there are a lot of them. Okay, and so I will go ahead and when I finish messing around with these other highlighted nebulosity points here, or pixels, move on to the star repair. Alright, so now that I've got my mask, I'm going to play around with the different algorithms and see what we get in terms of the stars. Like I said, for this, I like to redistribute, it's probably the best, but again, it kind of makes the stars look fake. So I'm going to hit do. And now it's done, and I'm going to tell you that I don't like it. And you can see several of the stars look very round, very fake. They got sharp edges. It's just, So I'll try another one, but again, I just don't like it. Just showing you guys what it looks like. You can do this with your photos if your polar alignment, if you're using guiding and things like that, and I would imagine that StarTools will do a better job on a guided photo. I don't have guiding, so my stars are a bit elongated, a little bit too elongated for StarTools to handle. So again, that's the reason for having guiding. It improves the roundness of your stars. And by the way, if you have guiding, you probably don't need to do this kind of repair. You can just use star reduction in GIMP or Photoshop, and you're done. Save yourself having to use StarTools for that purpose as well. So let's finish this up here. Modifying the stars. Again, you start looking at those stars. They're again round with sharp edges. It's just not feasible. Some of them are double stars that is turning into single stars, so it's just messing up the picture, and I don't like it. I like the picture to be as true to natural as possible. So I'm going to stop it here. Alright, so last thing we want to do is save it. We're happy with it. We've done the best we can, so let's save it. And you have to remember to, as you name your object to be saved, you got to remember to put in the .tif extension at the end. I'm not sure why StarTools doesn't just automatically do that for you. It will crash if you don't do it. So, alright, so that's it. StarTools.
So after having months of clouds and rain, we've had about a week of sunshine and clear skies at night, and I've taken full advantage of that. So that's where this particular workflow came from. So hopefully it's helped you, and thanks for watching. Again, my name is Kevin Francis, astrophotographer. Don't forget, the sky is only the limit when your mind is unwilling to fly. So go beyond. Thanks for watching.